You know, we're all getting pretty used to having AI around. It's in our work, our phones, pretty much everywhere. But there's this hidden danger, something that can turn these incredibly powerful tools against us. It's called data poisoning, and it's an invisible threat that can literally teach an AI to lie, to mislead, and to make some really dangerous mistakes.
To really wrap your head around how serious this is, you got to see it for yourself. And what we're about to look at, it isn't your average AI glitch, like getting a math problem wrong or saying something funny. No, this is way more deliberate. And honestly, it's pretty concerning.
Okay, so take a look at this. On the left, we've got a normal 30 km/h speed limit sign. Simple enough. But on the right, that's what the AI in a self-driving car sees, an 80 km/h sign. Now, this isn't a bug or a glitch. This is a manufactured mistake, a blind spot that was intentionally planted inside the AI's mind.
And that right there, that's the absolute heart of the issue. The AI in that example, it actually performed perfectly based on its training. The problem wasn't the AI's logic, the problem was its teacher. It was deliberately taught the wrong lesson.
So, that malicious teaching has a name, and that's data poisoning. Think of it as the secret ingredient an attacker slips into the recipe to corrupt an AI from the inside out, long before it ever makes a single decision for you.
So what is it exactly? Well, data poisoning is when someone intentionally feeds a machine learning model bad, corrupted data while it's in its training phase. The goal could be anything from just messing with its performance to introducing a specific bias or, and this is the really insidious part, to manipulate its answers in very specific, targeted ways.
This is such a critical point to understand. The AI model itself isn't broken or defective at all. It's like a really diligent student, doing exactly what it was trained to do. The poison isn't in the AI's code. It's in the textbooks it was given to study from. Okay, so how do attackers actually do this? Well, it's not just one trick. They have a whole toolkit of sophisticated methods, and each one is designed for a different purpose and, well, a different level of sneakiness. Let's break a few of them down. The most common ways they get in range from pretty straightforward to incredibly stealthy. You've got label flipping, which is a simple way to just confuse the model. Data injection is where they add totally new fake data. But then you get into the really advanced stuff like backdoor and clean label attacks, which are designed to be way, way harder to spot. Let's just compare two of these to see what we're dealing with. Label flipping is basically a brute force attack. You just swap labels, you teach a spam filter that dangerous emails are actually fine. It's messy, it's noisy. A backdoor attack, on the other hand, is surgical. The AI works perfectly fine 99.9% of the time until it sees a secret trigger. Think of it like a sleeper agent. The trigger could be almost anything: a specific word, a tiny watermark in a picture, a particular icon. As soon as the AI sees that trigger, it executes its secret malicious command, just like we saw with that speed limit sign. But maybe the most devious of them all are these clean label attacks. Here, the poison data looks completely normal. It's even labeled correctly. The manipulation is so tiny, so subtle, like an almost invisible pattern added to a picture, that it just sails right past human inspection, making it incredibly difficult to catch.
Okay, this all sounds pretty technical and scary, but what does it actually mean for us in the real world? Why should you care? Well, the impact can range from losing some money to, well, something much, much worse.
This is where it gets genuinely chilling. A study from the Mayo Clinic actually poisoned a medical AI that was trained on breast cancer data. And what they found was that a poisoned model could be tricked into recommending the wrong drug, replacing a totally normal painkiller with something completely incorrect. The implications of that are just staggering.
And how hard is it to pull something like this off? You'd think it would take thousands of malicious files, right? But research from the Alan Turing Institute found something truly shocking. It can take as few as 250 malicious documents to successfully poison a huge language model. And that number stayed about the same no matter how big the model was. Just 250.
And the effect of even a tiny amount of poison is dramatic. Just look at this chart. In one study, poisoning just 3% of the training data, that's it, 3%, caused the error rate in a spam detection system to jump from a respectable 3% all the way up to 24%. That is a massive 8-fold increase in failure from a tiny bit of corruption. So, yeah, the situation is pretty serious, but it is not hopeless. The cybersecurity world is working hard on ways to defend against this threat. The key, really, is to stop being reactive and start being proactive. There's no silver bullet for this. You can't just install one piece of software and call it a day. Defending against data poisoning requires a multi-layered strategy. It's all about building a whole series of checks and balances throughout the entire life of the AI. So what does a good defense look like? Well, it has layers. It starts with rigorous data validation, knowing where your data is coming from and that you can trust it. Next, anomaly detection tools act like automated security guards, flagging suspicious stuff. Once the AI is live, you need continuous model monitoring to look for any weird behavior. And of course, simple access controls are crucial to stop bad actors on the inside. Finally, there's a really cool technique called adversarial training, where you basically vaccinate the model by showing it bad data in a safe environment to build up its defenses. All of these defenses, all these strategies, they bring us to the fundamental challenge that data poisoning throws at us. Because this isn't just a technical problem, it's really a question of trust. This quote just hits the nail on the head. At the end of the day, an AI is a direct reflection of the data it learned from. If we can't trust the integrity of that data, we can't trust the AI. It's really that simple. And that leaves us with a massive question, especially as we weave AI deeper and deeper into our society, into our medicine, our finances, our cars. If the very foundation, the data, is vulnerable to attack, how do we build a future where we can truly, fully rely on an AI's judgment?